Hello, my dear student. Thermodynamic concept of energy. You know that energy will neither be created nor be destroyed. It simply converts from one system to other system. And the concept of energy deals in first law of thermodynamics, right? Before understanding of the thermodynamics point of view energy, we try to understand that there are two terms which is frequently used in thermodynamics. What is that? One is the change, one term is change and other is transfer. If someone says that change of energy and someone says that transfer of energy, what is the difference between change of energy and transfer of energy? See, change in generally, change is always system properties. That means it is within the system, right? But transfer, not a system property, not a system properties. That means what is that? It is a boundary phenomenon. It is boundary phenomenon, right? That means it should cross the boundary. It always cross the boundary. That means it is a boundary phenomenon. The point function or a state variable. That means if the point will changes, this quantity will change. Yeah, a state will changes, this quantity will change. But transfer always a path function. Path function. So if it is a point function, this is exact differential. This is your exact differential. And if it is a path function, this is your inexact differential, right? The example, internal energy. And in this category, the example is a heat and work, right? Now, next is that if the process is cyclic, if the process is cyclic, change always zero. Change is equal to zero. But if the process is cyclic, in the case of transfer, if the process is cyclic always gives area, always gives area enclosed by the cycle. That means if change is change in anything in a cyclic process is zero, but transfer in anything in a closed cycle gives the area. That is, if we draw, if we draw right. So this is the change in property and transfer of anything. That means change in a quantity x and transfer in quantity x. You can write also like that, d of x. This notation of the change in the quantity of x. This is the notation of transfer of the quantity x, right? If you write what is the transfer, that means x1 to 2, and what is the change, that means x2 minus x1. That means it is exact differential, it is inexact differential. It is the x quantity is the system property. In this case, x quantity is not a system property. It is stored within the system. It is transfer between system and surrounding. That means it is a boundary phenomenon. It should cross the boundary. In case of cyclic process, this change in quantity is zero, but in the case of cyclic process, this transfer H quantity is always gives area. With the area, right? So these are the terminology which is frequently used in a thermodynamics, right? Now, come back in the thermodynamics point of view, what is the energy concept? See, in a thermodynamics, there are two types of energy. One is the energy stored. That means it is a system property. And one is the transfer. That means it should cross the boundary, right? The example is that internal energy. That means if you take a change in internal energy, it is exact differential. That means E2 minus E1. And if it is cyclic, this will zero. So it is a point function and or a state variable. Energy transfer, that means the energy which is boundary phenomena is work and heat, and it always a path function. That means it is not a property, it gives always area enclosed by the curve, by the curve. So this is your concept of energy with respect to thermodynamic point of view. So in a thermodynamics, only two type of energy. One is the stored phenomena and other is the transfer phenomena. The stored phenomena generally use internal energy and transfer phenomena use work and heat. Okay, I think you understand. Thank you.